unmute, start my video, and head there and stop my share for a minute. Okay, couple things before, oh gosh, huge. Couple things before we get going totally today. I wanted to give you a heads up about lab. So this is my favorite nerdy t-shirt. I've actually had it way before I started teaching chemistry, but it says, I'll put it on so they can see it. It's backwards for them, but it says without stoichiometry, there would be no cupcakes. Chemistry rules. So stoichiometry, Lily, are you with me? Stoichiometry, Lily, are you with me? So stoichiometry is basically the type of chemistry we use to decide ratios. It's like recipes. And the reason I'm giving you a heads up on this is you guys don't cover it a lot, but today's lab is on stoichiometry. So it would be helpful to know what you're doing before you get there. So it's kind of like if you were going to bake chocolate chip cookies and the recipe said you needed 2.5 cups of, let's say the recipe says you need 2 cups of flour and 1 egg and 2 cups of sugar. I'm making it up. I know the recipe by heart, but I'm making it up. All right. So if you wanted to double that recipe, you would need 4 cups of flour and 2 eggs. Right. Exactly the same thing. Yes, it is related to the coefficients. And here's why. So the coefficients in chemical equations, the big numbers in the front of the molecule or the formula unit, the big number in the front, the coefficient, we use that as what we call a molar ratio. So if you have 2 in front, oh, somebody showed up. Oh, good, here we go. So if you've got 2 in front of one and 3 in front of another, those coefficients will represent your ratio. And if you change one number in the ratio, you change all the others. But it does help you
I'm
find
sorry for
how many.
late.
Hello. It does help you find how many moles of something you're looking for. And so today when we do our lab, we're going to try and find out how concentrated or how many moles of our solute are dissolved in our water. You won't know when you begin. There's one they're going to mix 2 solutions together. One you'll know and one you won't. And you'll be able to tell how much is in the one you don't know based on the one you do know, because you're going to produce a particular product. And the numbers are always the same. So think of it like that. It's like recipes and like a balancing act. So we need to start, our fun escape room. So you guys are going to work together. Oh, yeah? I missed it. Where'd it go?
5 and we kind of.
Oh, you're 5 and you couldn't escape. Well, hopefully today we will escape. I had it up, but it seems that unless it's, no. All right, so.
It said reactions.
Yeah.
There was a lowercase r. I was like, what is this Reddit subreddit?
So yeah, that's funny, isn't it? So this is actually the password that you need to get in here. So we're going to use this.
R. I was like, oh, it's like r/something. I was like, wait, why are we at subreddits in chemistry?
So here's our team. And this is.
I can't see anything.
You can't see anything? Okay, hold on. Let me make sure it's working.
I'm trying to read from this photo.
Hold on here. Can you see it now, Jocelyn?
No.
No. Okay, hold on. It says I'm sharing.
She see just the names and no pictures?
I don't know. What do you see when you're looking around?
Black.
Yeah, I don't see you either. You know what? Did you just dial in instead of do video? Is that it?
What does that mean?
I don't know. Maybe try logging out and logging back in.
Okay.
All right, I'll look for you. All right, so here is our virtual escape room. And what we have to do here is we're going to do like a step at a time. And you guys are going to help each other out. We're going to find our way through. All right. So you're probably going to want some paper and a pencil because you're going to need to write some things down. Some little scratch code things. All right. Morning, Jules. Hi. Morning, Ella. Hi. So what I was just telling everybody is 2 quick things. Today's lab, I wanted to give you a heads up on today's lab. It's my nerdy t-shirt that says without stoichiometry, there would be no cupcakes. And you can think of stoichiometry like a recipe. Like if your recipe says, here's a good one, peanut butter and jelly sandwiches. You need 1 tablespoon of peanut butter, 1 tablespoon of jelly, and 2 slices of bread, okay? I'm just saying. Say you, okay, but wait a minute, don't get off. Say you wanted to make 2 peanut butter and jelly sandwiches. How many tablespoons of peanut butter would you need? 2. And how many slices of bread would you need?
4.
4. That's right. So that's what you need to do.
I see it now.
Okay, I'm trying. Can you see me now, Jocelyn?
Yes, I can see
Can you see my screen? All right, good.
everything.
All right, so
now.
we're doing an escape room today, a virtual escape room. So we're all in this together. Jocelyn's with us, even though she's not here. And can she get in? Okay, hang on a second. I have so many, working on my iPad says you have another meeting in progress that I can't get into because it's invalid. Hang on a second. Go to last week's email period. It has all the new information. Okay. Oh, she's trying to get in this way. Sorry. All right. So what we're going to do is we're going to do this escape room together. It should take about the length of class, and we're already a little behind, so we may not get to finish it. I may just send it out to you guys to finish at home for fun if you want. So you may want some scratch paper. So here we go. Let's begin. The law, it says it won't let her in. Okay, hold on. Working on my iPad says that. Oh gosh, she's stuck. Let me see if I can help her. Oh, yeah. Can't I invite her in somehow? Let me see.
Who? Me?
No, Senya is stuck somewhere. Let me do it this way. I'm gonna do it. Hang on one sec. I gotta open a separate window. And I gotta send her back a thing. So she's stuck over there. Sorry, y'all. Just give me a second. I really would like everybody in if I can. And it's too hard to try and do it backwards. All right, let's try that. All right, back to our escape room. So the law of conservation of mass states that matter cannot be created or destroyed. In terms of chemical reactions, this means that the matter at the beginning of the reaction must be exactly the same as the matter present at the end of the reaction. All matter is made up of elements and compounds, or a combination of both elements and compounds. All elements and compounds are just a collection of atoms. So you got an atom, and then you got a compound right there in your little diagram. Because all matter is composed of atoms, another way to state the law of conservation of mass would say that the atoms that are present before a chemical reaction must be exactly equal to the blank present at the end of the reaction. What's our answer?
Atoms.
Atoms? Does anybody disagree? Do we want to go with atoms? Because all matter is composed of atoms, another way to state the law of conservation of mass would say that the atoms that are present before a chemical reaction must be exactly equal to the blank present at the end of the reaction.
Like atom, not plural.
Do we want to go with atoms, or do we want to try something different? Different? Who says atoms? Raise your hand. I agree with Alec. I'm gonna say atoms. Let's see what we get. Next. Boom, look at that. We made it through. All right, now you will most likely need the following link to help you answer these questions. All right, so this one's going to be fun. Let me see, did she not get through? I don't know what to do with this. I'm tapping it and I'm asking it to launch the meeting, but it won't. Weird. This is Senya and she's stuck. And I don't know why she's stuck. One more second. Let me see. Oh, I've sent her a couple different things. I did send her the Zoom link. I sent her a couple of things. I think she's on her mom's iPad. Okay, so we're going to have to go to this link right here and read this, which is super cool, just so that you know. So here we go. This is about Antoine Lavoisier. Antoine Lavoisier is often called the father of chemistry. All right, so here's some stuff about Antoine Lavoisier. He was a chemist, and he was born August 26, 1743 in Paris, France. You're going to want to pay attention to all this because they're going to ask you questions about him, okay? And he died May 8th, 1794 in Paris, France. He is best known as the founder of modern chemistry, or the father, depending on who you're talking to. So Antoine Lavoisier was born in Paris, France, August 26, 1743. He grew up in an aristocratic and wealthy family. Y'all know what aristocratic means?
No.
An aristocrat, like that's like the high class, like the special people, not the little peons. Yeah, not the working class people. No. Nope, French. Antoine discovered his love for science while attending college. However, he initially was going to follow his footsteps and earn a law degree. Lavoisier never did practice law because he found science much more interesting. He had inherited a good deal of money when his mother died and was able to live as a nobleman, pursuing various interests. Oh, how nice. Lavoisier worked in various government positions and was elected to the Royal Academy of Science in 1764. In 1775, he set up a laboratory in Paris where he could run experiments. His lab became a gathering place for scientists. It was in this lab where Lavoisier made many of his important discoveries in chemistry. Lavoisier considered it important to use experiments, precise measurements, and facts in science. Okay, 1 second. I'm going to check on Senya. Do I have anything else from Senya? No, she's stuck somewhere, I guess. Okay. One of the main scientific theories of Lavoisier's time was phlogiston theory. This theory stated that fire or combustion was made up of an element called phlogiston. Scientists thought that when things burned, sorry, I can't speak today, they released phlogiston into the air. Lavoisier disapproved of the phlogiston theory, and he demonstrated that there was an element called oxygen. Oh, good. Did she just make it? There was an element called oxygen that, where did I lose my space? That played a major role in combustion. He also showed that the mass of products in a reaction are equal to the mass of the reactants. In other words, no mass is lost in a chemical reaction. This became conservation of mass and is one of the most important and basic laws in modern chemistry and physics.
Hey, Danny, I just got in.
Hey, yay, she made it. All right, so we're in a virtual escape room, Senya. So,
What?
yeah, we're in a virtual escape room. So if you listen to this bit I'm reading here, which you should see on your screen, then we're gonna have some clues in here that'll help us get out of the room. So he spent a lot of time isolating elements, Lavoisier did, and breaking down chemical compounds. He invented a system for naming chemical compounds. So this guy really did do pretty much everything but the periodic table, didn't he? Do you remember who did the periodic table? Mendeleev. Much of his system is still used today. He also named the element hydrogen. During his experiments, Lavoisier discovered that water was a compound made of hydrogen and oxygen. Prior to his discovery, scientists thought throughout history that had thought that water was an element. And he wrote the first chemistry textbook, which was in 1789, the Elementary Treatise of Chemistry. And it was the first chemistry textbook, contained a list of elements, recent theories, and laws, including conservation of mass. Now, here's where it gets really interesting, a little morbid. The French Revolution. You know about the French Revolution? Do you remember who's king? Yeah, Louis XVI and his wife, Marie Antoinette. Do you remember that, like, they had all the money for themselves and people were starving in the streets, okay? And Marie Antoinette made that famous let them eat cake. Actually, she said let them eat brioche. Yeah, okay, yeah. So the French Revolution began in 1789. Lavoisier attempted to remain separate from the revolution, but because he had worked as a tax collector for the government, he was branded a traitor. On May 8th, 1794, he was executed by guillotine. What's the guillotine do?
Slices off people's heads.
Right off. Mhm. A year and a half after he was killed, the government said he had been falsely accused. Whoopsie, we executed him. Whoops, sorry. So his wife, Marie, his wife, Marie, played an important role in his research and helped translate documents from English to French so he could study them. She drew illustrations. Marie Lavoisier is one of the like sort of underappreciated female scientists in history whose husband got all the.
Was she really the scientist, or was he the scientist?
They worked together. She did a lot of what he did. A lot of what he did, he couldn't have done without her, or it certainly wouldn't have been left for posterity the way it was because of her diagramming and translating. Lavoisier did experiments with breathing that showed that we breathe in oxygen and breathe out carbon dioxide. He worked as a commissioner of the French Gunpowder Commission, and one of his elements listed in his textbook was light. He was a little off there. He demonstrated that sulfur was an element rather than a compound. Okay, so now we have a little background on Lavoisier. Now here comes some questions, and we're gonna have to answer these by putting the letters in. It says here, law of conservation of mass was proven by a French chemist named Antoine Lavoisier. He is known as the father of modern chemistry because his research into law of conservation of mass changed the science of chemistry. Before Lavoisier, it was believed that the products of a chemical reaction could contain atoms that were not present in the reactants. Once Lavoisier proved this to be false, the whole idea of chemistry was changed forever. So here are some questions. It says to create the unlock code for the next step of the assignment, put the letters of the correct answers above in order and use only uppercase letters. So we start here. How old was Antoine Lavoisier when he died? So let's go back and look. Okay, he was born August 26, 1743, and he died May 8th, 1794.
He was 51.
51, says Senya.
Yeah, I agree.
51. Anybody disagree?
No.
Are we taking months into consideration and everything? We're good to go?
No.
Yeah.
Well, our
51.
choices are 51, 61, 50, and 60. What do we think?
51.
51? Okay. Which element did he name? Helium, carbon, nitrogen, or hydrogen?
D, hydrogen.
Okay, who votes for hydrogen? Oh, hydrogen wins. Let's go for hydrogen. Okay. Before Lavoisier, what did scientists think was the cause of fire?
Hey, fire.
Phlogiston, carbon, hydrogen, or hydrocarbons?
Duh.
Phlogiston, do we all agree with that one? Okay. How did his wife help him in scientific research? By doing experiments, translating documents, or writing down his findings?
B,
B?
translating
B.
documents.
All right. In what way did Lavoisier die?
Guillotine.
What do we say?
No.
Guillotine? What do you guys say?
Yeah.
Guillotine? Guillotine. All right. So let's see. Let's see. Uh-oh. Something's wrong.
There's months difference. Go back and choose 50 instead.
Well, let's look. Which one are you least confident about?
First one, H, because there's months difference. We should put it 50.
There's months different. Okay, that's a good point. So wait, let's look at the months again.
It was May and August.
May and August. So what does that mean? Does that mean he is 50 or 51?
50.
We put in 51. 50. He hadn't gotten to his birthday yet, guys. He was close, but no cigar. Let's give it a shot. Oh, yes, we have moved on. Chemical equation basics. In a chemical equation, symbols are used to show how a chemical reaction occurs. The left side of the reaction equation identifies the reactants of the reaction. Reactants are elements and compounds that begin the reaction. The right side of the chemical equation is an explanation of the products. Products are the elements and compounds that are produced by a chemical reaction. Also included in many of the reactions is the state of matter, right? And this table shows the symbols. So, you know, you have your gas, solid, liquid, and aqueous, which would mean it's dissolved in water. Reactants, products, there's a good diagram, right? In the above equation, the reactants are hydrogen gas and oxygen gas. Do we see that? Hydrogen gas, oxygen gas. And the product is liquid water, right? Y'all with me? To build the password, use the letters that answer the questions below and put the answers to each individual question in correct alphabetical order. Okay. So after you've alphabetized each individual answer, combine the answers in order. All right.
So what letters do we have to use? All those in the top or do we have
So
letters?
if it says, for example, which letters above, meaning this line here, show the products of a reaction.
C and D, can I put
Right, but we can't do D and C because they have to be alphabetical. So we have to write it as C and D. You guys understand that one? All right,
Yeah.
so let's put those in, the first one.
capital C?
Okay. How about number 2? Which letters above show gases?
B. That's the
B.
only one that says G.
We all with B? Okay.
Yep.
All right, how about this one? Which letters above are substances dissolved in water?
A.
Yeah, it just means it's dissolved.
What do you guys say over there? Lily, what do you say? Dissolved in
A.
water? Ella?
The A means it's dissolved in
A, yep, aqueous, right? All right, how about which letter above are the reactants of the reaction?
B.
Reactants, think about it.
D. D.
D,
Wait.
C, D.
E, C, D are the what? We said C and D were the products. So what are the reactants?
A, B, and A.
Yeah, B and A. Can I write it as B and A or do I have to write it as, I have to write it as
A
A
and B.
and B? Right, okay. Which letters above show the substance are solids?
C.
What do you guys think?
The C.
C, everybody agrees with C. All right, Jules and Eleanor, you look at this last one for me. Which letters above are liquids? What's the liquid?
It's an L.
Look for the L.
It's like a one.
Do you see it?
D, L.
D, yeah. All right, let's give this a shot. Are you ready?
Yep.
Fingers crossed.
That seems right.
Boom, nice. We made it to room 5. We're getting out of this building or wherever we are. Now it's chemical equation. Because the law of conservation of mass, a chemical reaction must start and end with exactly the same number of atoms for each element in the reaction. As an example, here we have water, right? H2 plus O2. The reactants in this equation contain 2 atoms of hydrogen and 2 atoms of oxygen. The product contains 2 atoms of hydrogen and 1 atom of oxygen.
We have
So,
leftover oxygen.
right, the reaction above is impossible because it does not start and end with exactly the same number of atoms of each element. There is the same amount of hydrogen, but the oxygen appears to have disappeared, right? We're missing an oxygen over here, aren't we?
Correct, the bottom one.
Right? So Antoine Lavoisier proved this was impossible. Oxygen atoms cannot be destroyed. In other words, all chemical reactions must be balanced. They must contain exactly the same number of atoms of all elements in the reactants and products. So how about this one? Is this one balanced?
Yes.
What do you guys think?
Yes.
Yes.
Yes. Wait.
Yeah, it is, right? The above reaction can occur.
One oxygen, and if
Which is
you
balanced.
multiply 2 by 2, that's 4, which means you have 4
Yep.
oxygen, 4 hydrogen plus 2 oxygen, which would equal 2 H2O.
You got it. So now this says we're going to identify the chemical equations that show balanced reactions. And to build the password for the next page, use the numbers of the balanced chemical reactions above and put the balanced equations in order from largest to smallest. Do not put any spaces in the password. So meaning we have to look at each one, and if it's balanced, we put the number for it, but it has to be largest to smallest. So we can't do them out of order. Okay. What do you guys think? Is number 1 balanced? Ella says no.
No, because
Yeah,
you don't.
okay, how about number 2? Why don't you guys look? You tell me which ones are balanced.
No. Number 2 is not balanced. No.
Mhm.
Not balanced.
Okay.
Yes. Number 3 is balanced. Yeah.
Number 3 is balanced. So we want to put number 3 down? Okay, 3. All right.
It's 3. If the answer is 4, 3.
Can't be backwards.
4 isn't balanced. 3, 4? 4 is not balanced.
4 is not balanced? You sure?
No, it's 4, 3 because that's the largest to smallest. Yeah, it's not balanced.
Okay.
Final answer. Wait, no, it is. It is.
There you go.
It's balanced.
Do we agree? Is 4 balanced?
Yes.
What do we think? Yes, no? Yes. Okay.
Yes. Don't we have-
How about number 5?
No. Yeah. Wait, no, wait.
CL, CL, NA, 2, NA. Well, look at it this way. We have barium, right?
No,
Yep.
because there's
One.
there's not enough.
And 1. How about CL, chlorine? We have 1, 2. We have
3. There's only 2.
1, 2, right?
That's not balanced.
Sodium, 1,
That's
2. So is it balanced?
No.
No. All right. How about this last one?
No, because there can only be 2 ends, and then there would be 6 in that. Wait, no, actually, that's balanced. That's balanced.
2
Sorry.
N is 2, 2N. H is
balanced.
how many here? 6.
That's
Okay,
6.
so we're gonna go with. All right.
6, 4, 3. We have to put it largest to smallest.
So what does it say? Put the numbers from largest to smallest. So he's right. So it's going to be 6, 4, 3.
And that's the answer for
6, 4, 3. And let's see. Fingers crossed. Oh, we are doing good, guys. All right, now it says your friends aren't feeling so good. All that food is starting to give them a tummy ache. Oh my goodness.
What food?
I don't know. I guess they've been eating, huh? Man up. Are you going to be able to help? In a chemical equation, the numbers in front of each element or compound are known as coefficients. To balance a chemical equation, you must change only the coefficients. The small numbers of the equation are known as subscripts, right? Coefficients in the equation above are 2, 1, even though you don't see it, right? And 2. These are needed to balance the equation. Chemical equations below are unbalanced. You must find the coefficients that will balance the equations. Can you determine the correct coefficients needed to balance these equations? To build the unlock code for the next step of the escape room, you must find the coefficients that are required to balance the red blanks. There's 3 numbers for each equation. Put the numbers in each equation in order from left to right with, oh, hello, TV went to sleep. Okay, I don't know what that's about. With no spaces, the 3 separate codes should be combined to make a 9-number code. I'm off. Oh, our internet went out for a minute. That was the problem. Here, I'll get it back though.
Zoom calls gonna be broken.
No, I think they're okay. They're still on. But
You would need to put a 2 in front of both MG.
Right, give
For
me a
the
second. Get
first
they can't.
time
You
you would
girls
have
at home can see. Jocelyn, Senya, you can see the screen, right?
Yeah.
Are you there?
The answer for the first equation.
Yeah, we just,
Yeah.
Hang on.
yeah.
You need to
Jocelyn,
put a
Senya, are
2
you
in
guys
front of
there or did we
MG
lose you?
and the MGO. What?
We're here.
Here, can
We're
you
here.
can you still see the screen?
Yeah.
Okay, you
Yes.
start working. The screen share here just died, so I have to get the TV back up again. So y'all work on that real quick if you can see them.
I
Start-
figured out the first one.
All right, you write down what you've got. Hold on a sec till I get there.
It's 2 on 2.
It's 2 and 2.
2 on 2.
Oops, hold on.
It's 1.
This is the wrong one. Don't do that. Click the wrong button.
What do we do with the piece of paper that we?
Well, you're just using it as scratch paper, Drew. Why does it keep doing that? Here. Oh, jeez, come on. Oh, wait. No.
You have to select the name of the device is shown.
You know, what I have to do actually is take this one off and put it back on because it doesn't like to, it likes to find it every time. If it's in the list, it doesn't understand. Why? I don't know, but there we go. Okay, so it should be going here. Fingers crossed. All right, it won't let me minimize. Sorry, girls. Okay, should be coming up in a second in here. So, all right, there you go. So you girls at home found, what was the first one, Jocelyn? Did you say you had it?
For the MG and the MGO, you gotta put 2.
2. And then What else? Anything else?
No,
You gotta have
because
three.
then you got a balanced equation.
So do we put a 1 here where the oxygen is? Because we have to have a number.
Yeah.
Yeah, we wouldn't write that number, but they want it for this. Okay, so what's the next
Jenny,
one?
it says these separate codes should then be combined to make a 9-number code.
Yep. So there should be 1, 2, 3, 4, 5, 6, 7, 8, 9. So we have 3. So now we're on this one with sodium, oxygen. All right, guys, you tell me. What do we have to do?
4, 1, 2.
4, 1, and 2.
Whoa.
2 times 2 is 4.
Yeah, 4, 1, and 2. I got the exact same.
How about any of you? You got anything different? 4, 1, 2. Is that what we're gonna go for?
Yeah.
All right, now how about the last one?
3, 3, 2.
3, 3, 2. What do you think?
Actually, yes, that would, no, because N wouldn't have anything. No. No.
Put a 3 in front of this N. We're gonna get 6.
We're gonna have to put a lot more in the first N than the.
And if we put a 3 here, we're gonna get 6. If we put a 2 here, we'll have 4 and 6. Almost. What are we gonna do?
2, 3, 2.
2, 3, 2. So this becomes 4, 6, 4, and 6. I think 2, 3, 2 is good. That sound good to everybody else?
Yep, enter.
Ozzy, goodness. All right, let's see. All right. Oh, something's off.
It's the last one.
Let's look here. First one, we said 2, 1, 2. So if we have 2 magnesium, we'll have 2 magnesium. If we have 1 oxygen here, it's actually 2. And then if we have 2 here, that'll be 2. Do we all agree that that's right? Yeah. All right, so let's look. Sodium, oxygen, we said 4, 1, 2. If we put 4 sodium here and we put a 2 here, that will give us 4 sodium and 4 sodium. Yeah. And then if we put, what did we say? 4, 1, 2. We put a 1 here, that gives us 2 oxygen. And we had what over here? A 2. You know, yeah, 2. So that would be good. So let's look at the last one again. Let's see then. We have 2. So that's 4. And 2. So that's 4. 3. Okay. So did we write this wrong? Let's see. There will be 3 numbers for each equation. Put the numbers in each equation in order from left to right with no spaces. The 3 separate codes should be combined. So where are we off? What did we do wrong?
You would multiply 1 times 2 because there's 1 N.
Which one are
And
you?
you would, for the last one,
The last one,
it would be 2, 3, 4.
2. So the 2 times 3 gives us 6. 3, that gives us 6. And then what were we saying here?
Because you only put a 2, so and the
2, 2, 3. 2, 2, 3, 4.
3, 4. Okay, so if we put a 4 here, we'll have 4 N, and then we'll have 12
No.
hydrogen. So wait a minute. If we put a 4 here, and we have 12 hydrogen, what do we need to put here? 2, 6, 4. Let's try that. And let's see. Okay, now what are we missing? Anybody writing it out? Anybody balancing?
I'm writing it out.
Hi, girl. 2.
Eek, this is confusing.
Yeah, let's look at it this way. You guys writing it down?
Yeah.
So if we have where's my little pen? N2, it's hard to write with this thing. Plus H2. This is so hard to write with my pen's about dead, so I can't do anything with it. And NH3, right?
Mm-hmm.
Okay, so the next thing we do is this deal, right? All right. How many nitrogens do we have?
2.
2 nitrogens. How many nitrogens do we have over here? We only have 1. So if we needed to have 2, then we're going to have to put the 2 here, right? Okay. How many hydrogens do we have?
1, 3, 2.
We have 2, right?
Yes.
Hydrogens do we have over here? We have 3,
I think I figured it out.
6. Oh, you did?
Yeah, I think I did.
How about a 3? What'd you get?
You put a 1 in front of the N2 because then the two in front of the NH3, you would still have 6 hydrogen, and
Mhm.
1 times 2 is 2. So it'd
Right.
be-
We should have 1, 3, 2. We agree on that?
Yes.
1, 3, 2. All right, let's try it. 1, 3, 2. All right, fingers crossed this time. Hey! Oh, now look what we
Yay!
have. More equations.
No!
You guys are gonna have to
You might want to
write.
erase that screen.
Yep, there we go.
We have to write all that?
Yep, you gotta figure that out. So let's see. Actually, I'm gonna get my pen because it'll be
Okay, so-
easier. Grab my pen.
The first AL3 should have.
Write it out. Keep that paper, right? I don't think we're gonna get out of this escape room. I'm gonna have to send it out for you guys to try and figure it out at home. Maybe there'll be a prize for those. There's a code when you get to the final room. Maybe
How many rooms are there?
I don't remember. I'll have to look.
We'll have
What?
a prize.
She's like, what? I don't I can't
Hey,
remember. I just know there was a good amount. Oh shoot. Come back. Actually get it. I can't, don't have room there. Ran out of room.
FeO3 plus Al3 equals AlO3 plus F.
EO3 plus AL3. Let's see if we can get at least one before we run out of time. ALO3 plus F.
F.
So
Now you must show that you really understand how to balance equations, just
Yeah.
as one of the previous page. You must find the confidences needed to balance each equation below.
oh boy. FE, we got 1 and 1. AL, we got
Then-
3
and
and
then-
1. So this needs to become 3.
I think I got it. 3, 1, 3,
3, 1, 3, 3
3, 1, 3, 3. Okay.
Yes.
for the first one.
3, 1, 3, 3. There we go. So what we're gonna do, because we are definitely running out of time, is I will give you the answers for up to this point, okay? Because I have all of them. So what I'll do is I'll send it out just for fun, okay?
Okay.
Give you the answers for what comes, what we've done up to this point. So you don't have to redo that work. And then I will have prizes. I don't know, some kind of prizes. Maybe, I don't know. I'll come up with something fun.
We get to go to.
Brownies.
Yeah.
There you go. I will have prizes for whomever sends me the code that lets me know that you made it to the end of the escape room. Anybody who does it. All right, so Jocelyn and Senya, today's lab is posted for you already. So all
I
you
saw it in
Yeah.
teachers.
Yep, there you go. All you got to do is go through, watch it, fill out your information, and send it back. Everybody is going to be sending it in this week, completed, so I can see it. Okay.
Okay.
And
Okay.
next week's lab, next week is the week before Thanksgiving, believe it or not. And
Yay.
I know. And next week's lab is a live demo. If you can make it, awesome. If you can't, it'll be recorded. But what we are doing is we are collecting the solids from cigarette smoke. So we are going to have 2 smoking apparatuses set up. One will be for
I'll be one of them.
a filtered cigarette, and one will be for an unfiltered cigarette. And we're gonna smoke 2 cigarettes through these apparatuses and collect all of
You're
the.
gonna smoke cigarettes?
No, the machines are gonna smoke them. It's pretty cool.
Oh,
Yeah.
It's like healthier when you make it.
All right. So y'all tell Jocelyn and Senya you'll catch them next go round. And,
Bye.
yeah. Okay. Bye, girls. See you later.
See you later.
All right.